So we have three different integral transforms: Laplace transform, Fourier transform, Mellin transform, and then we can also mention one more transform, and that transform is called Henkel transform. It is H-A-N-K-E-L, Henkel transform, and it is something like this: F nu S. This is equal to integral from 0 to infinity t times j nu s of t. J is a function of s of t, f t dt, where j nu s t is the Bessel function. It's the Bessel function of order nu. So these are some integral transforms, and out of these four integral transforms, we are going to discuss only Laplace transform and Fourier transform in our course. So let me start with Laplace transform. So let us start with Laplace transform. Laplace transform. What is Laplace transform? Okay, if capital F of t is a function defined for all t greater than or equal to 0, then the function f of s, the function small f of s, defined by the integral and what is the integral? F of s equal to integration from 0 to infinity e to the power minus st capital F of t dt. Let us call it equation number 1. So if f of t is a function defined for all values of t greater than or equal to 0, then the function small f of s defined by this integral is called the Laplace transform of the function capital F of t, and is denoted by L of f of t, or script LG mohta simple L ama seasonal. Some people use simple L, or some people use bar seasonal. That is the Laplace transform of the function f of t is given by integration from 0 to infinity e to the power minus st f of t dt. This is called the Laplace transform of the function capital F of t. So does Laplace this Laplace transform of the function f of t, it gives a new function of the variable s. I don't know, when I take the Laplace transform of the function capital F of t, I'll get a new function in terms of the variable s. So the Laplace transform of f of t is a new function of the variable or parameter s. let me mention here one point. The Laplace transform of f of t is said to exist. Is said to exist if the integral given by equation 1 converges for some values of s. For some values of s, otherwise it does not exist. I repeat, the Laplace transform of f of t is said to exist if the integral given by equation 1 converges for some values of s, otherwise the Laplace transform does not exist. Can you recall? One more thing is that the symbol L is called the Laplace transform operator. Laplace transform operator. Okay. So let me take a new sheet. We can show that the Laplace transform operator L is a linear operator. There is the Laplace transform operating on C1 capital F1 plus C2 capital F2, where F1 and F2 are two functions of t. This should be equal to C1 Laplace transform of F1t plus C2 Laplace transform of F2 of t, where C1 and C2 are constants. C1 and C2 are constants. This is the definition of a linear operator. So here Laplace transform is a linear operator. This Laplace transform acting on a superposition of two functions, f1 and f2. So the f1 is multiplied by a constant c1, f2 is multiplied by another constant c2, and we add them. This is called a linear superposition of two functions, f1 and f2. f1 and f2 are arbitrary functions of t. Laplace transform operator operating on this is equal to C1 Laplace transform operator operating on F1 plus C2 Laplace transform operator operating on F2. If the left-hand side is equal to the right-hand side, then we say that this operator is a linear operator. Okay. Next up, let us discuss about inverse Laplace transform. So this is about Laplace transform. Then there is the inverse of this transform. So inverse Laplace transform. Inverse Laplace transform. So if the Laplace transform of capital F of t is given by small f of s, then capital F of t is called the inverse Laplace transform. Inverse Laplace transform of small f of s. And we write and we write the Laplace transform. So there's a superscript -1 happen. We place the superscript -1. This is called the inverse Laplace transform. This is f of s is equal to capital F of t. This is the operator for inverse Laplace transform. So if Fs is a Laplace transform of capital F of t, then the inverse Laplace transform of small fs is capital F of t. These two are inverses of each other. So we can write thus the inverse Laplace transform of the Laplace transform of f of t is nothing but f of t. And similarly, the Laplace transform of the inverse Laplace transform of f of s is nothing but small f of s. There you go. So this is all about inverse Laplace transform. And what are the advantages of Laplace transform? The advantage of Laplace transform is that under this transformation, differential equations become algebraic equations. And algebraic equations are usually easier to solve than differential equations. So there is the advantage. And what is the disadvantage of Laplace transform? The disadvantage is that the formula for its inverse is a little relatively difficult to use. Okay, so let me make some comments here. Let me take a new sheet of paper.